Learn about Cloudify. We'll first have a brief introduction to the product and the motivation behind it. Then we'll overview the product's architecture and essentially the way it works and how you can deploy your own applications onto basically any cloud using Cloudify. We'll have two live demos during the session. The first one is going to be running an application on what we call a local cloud, which is basically a kind of a cloud environment running on my own laptop. And then we'll have the same application running on EC2. All right, so let's get started. So before we dive into Cloudify itself, I want to share with you a bit about how we got here in the first place. So GigaSpaces is essentially, if you're familiar with us, has been very active in the area of data scalability, in-memory data grids, more specifically. And we have a suite of products around that area, which is called ZAP or XAP, which stands for Extreme Application Stack. Our core, basically first product, which has been around for, I guess, almost 6 or 7 years now, is our in-memory data grid. It's designed to solve your data scalability problems. Essentially, if you're looking at applications that need to process massive amounts of transactions at high speeds and need to do it on commodity hardware in a distributed environment, that our data grid is a very good solution for that. As time passed by, we realized that it's not enough to scale just the data tier, and people also, and essentially applications, when you're trying to scale an application, it's very important that you do it all across the application, not just the data tier, but essentially every tier in the application. Because if you just scale one piece of your application, essentially you're transferring the bottleneck to another place. So based on our in-memory data grid technology, we basically kind of grew the platform onto a complete application scaling platform that's designed to scale your application from the load balancer or the web tier all the way to the database. And provides all the middleware services that a typical enterprise application will require, such as data access, messaging, business logic, and hosting mobile applications. Now, those kinds of applications were initially designed, or I would say were fundamentally designed to work on a distributed environment. That means that we're designed to use multiple hosts, multiple nodes to be able to dynamically scale in and out when needed. So when cloud computing kind of showed up about 3 or 4 years ago, it was a very natural transition for us to do. And the next phase in our product evolution was actually to take the same XAP or ZAP platform and to cloud enable it and make it run smoothly on cloud environments such as Amazon EC2 to begin with, Rackspace, and other environments. The next step, and basically as we developed XAP and the capabilities of that platform, we've also created a very, I would say, sophisticated management platform around it that's designed to enable you to seamlessly deploy and manage and provision XAP applications on multiple hosts. So it would take the same amount of effort to deploy a single instance or 50 instances or even 100 instances as some of our customers are doing. And we realized that one of the key value propositions for XAP users is actually that same management platform. And a lot of our users have been asking us to kind of open that platform to enable other applications to enjoy the same benefits. And I would say that that's a very fundamental key to understanding what Cloudify is all about. So Cloudify is about taking our, I would say, battle-proven existing cluster and application management infrastructure and opening it to as many applications as possible in a very generic way. So instead of, so if you're not an XAP user, you can actually take your existing applications and run them on any cloud environment, manage them, whether they're running on 50 or 100 or 200 instances, the same way you would manage them on your own local machine. Basically enjoy all the benefits that you have for ZAP applications. Okay, so to kind of summarize that and understand where we stand in terms of product portfolio. So we have the XAP suite that has two editions, the data scaling edition, which is simply the data grid piece of things. And we have the ZAP Premium Edition, which is the end-to-end scaling platform for scaling your entire application. And today we're introducing Cloudify, which is a new product. And again, although it's a new product, it's fundamentally not a new technology. It's based on existing technology, which has been tested and proven and running on leading Fortune 100 companies for the past couple of years. All right, so what is Cloudify all about? So I mentioned the idea or the kind of requirement to open the ZAP management infrastructure to multiple applications and basically application stacks. So Cloudify is all about onboarding any kind of application onto any cloud environment while still retaining control. And let's see what the goals are that kind of derive from this mission statement. So I mentioned any application, and it's not just a passphrase. We really mean it in terms of how we approach things. So Cloudify was initially designed, or was designed from the ground up, to enable you to take any existing application and to wrap it with what we call a recipe, and we'll learn what that is in a few minutes. Wrap it using the recipe and essentially deploy it onto any cloud environment. And the key thing here is that you won't need to change the application's code. So Cloudify is non-intrusive to your application. The second goal, which is equally important, is to provide what we call enterprise-grade capabilities to your application, whether it's running on your own private cloud or on a public cloud. That means continuous availability. Basically, if a node crashes, or if the complete server crashes, or if a VM crashes, we want to be able to continue and operate and basically recover from that condition. We want to be able to scale our application elastically. Again, if you're using, for example, a web server, it should be fairly straightforward to actually increase the number of instances based on load or based on any other custom metric that you would want to use for that purpose. Management and monitoring, we'll see that throughout the demo, provide not just basic management capabilities, but also the ability to define what you want to monitor and actually plug into the platform and expose metrics that are most relevant to you. So it's not just about CPU or memory, for example, or disk utilization. It's about, for example, how many objects are in a certain messaging queue, or how fast a certain database query is performing. These kinds of capabilities, we want to not just enable you to monitor them on your own, but actually expose them into the Cloudify management infrastructure and monitor and view those same metrics the same way you would any other metric. And the last bit is fully automated deployment. Again, when you're running, and this is actually something that people kind of struggle with when they first migrate to a cloud environment. It's just getting the thing running on the cloud in the first place. So Cloudify actually allows you to fully automate all of that cycle. Instead of manually booting machines on the cloud and installing software on them and making sure the packages are there and starting them and making sure everything's started properly, we want to be able to automate all of that process and provide what we call a full lifecycle support for your application. And last but not least, actually leverage the vast experience that we've gained throughout the years here in GigaSpaces when it comes to actually monitoring and actually deploying large-scale enterprise applications onto various environments. . Okay, so now that we understand the motivation behind Cloudify, let's dive into the details. So the first thing I want to talk about is the concept of recipes. You can think of a recipe as kind of a mediator between your application and Cloudify. So a recipe is actually designed to enable Cloudify to actually understand what your application looks like, what services compose this application, whether it's a relational database, a web server, a messaging queue, how those services interact with one another, and whether or not they depend on one another, how to present those services, how many instances to deploy for those services, and how to manage their life cycle. Essentially how to install them, for example, how to start them, how to stop them, and provide everything Cloudify needs to understand your application and to manage it properly. Now, the concept of a recipe is very important because it's generic, from the ground up. So it's not confined or constrained to any specific middleware platform. You can use JBoss or Tomcat, or just as easily MongoDB or Node.js, or whatever middleware component that your application requires, so long that it has a recipe that Cloudify can understand. So it's designed to basically, this is actually the glue that enables Cloudify to leverage the same management infrastructure that I mentioned before that we already use for XAP, and expose it to any component that actually our users need to use. In terms of architecture, Cloudify has a few main pieces. So the first thing you see on the left here is actually the what we call the user interfaces. Let me just annotate it. Okay, so we have a shell application. We'll see that in the demo. This actually enables us to interact with Cloudify from the command line. And we have a very rich web-based user interface, HTML5-based user interface, which allows us to monitor our environment and to understand what's going on. These two components communicate with what we call the Cloudify controller. The Cloudify controller is you can think of it as the brains behind the system. So it provides deployment capabilities. So for example, if you're deploying an application from the shell or from the user interface, the controller would be the endpoint with which those components interact to deploy the application. The controller would actually monitor the application once it's deployed and expose those monitoring metrics onto the user interface. And the controller will assess the state of your application at any given point in time and take proactive decisions to make sure it's providing the best service level it can. The controller is actually taking advantage or using a component that's called a cloud driver, the Cloudify cloud driver. This is actually the layer that isolates your application from the underlying cloud environment. So your application doesn't really care, or your recipe doesn't really care whether or not you're running on EC2 or on your own laptop or on a cloud.com private cloud. This is all transparent to the applications deployed to Cloudify using the cloud driver. So essentially the cloud driver is an abstraction layer that was designed to enable the cloud controller to interact with any supported cloud. Once an application deployed, and we're going to step through this process in a second, essentially Cloudify has an agent that's deployed on every virtual machine or on every physical host that is hosting your application. So the Cloudify agent is actually the thin layer that actually understands what processes or what services needs to be installed on the local VM. It understands how to monitor them. It understands how to self-heal them in case they fail, and it communicates back to the Cloudify controller and reports all the time about what's going on with each of the with the actual service that is deployed. So, for example, if you have a Tomcat service that's running within your VM, the Cloudify agent will actually connect to that Tomcat service via JMX, collect all the metrics that are required to monitor your Tomcat instance, and transfer them back to the Cloudify controller, so they're available for monitoring from the shell or the user interface. So now that we understood the Cloudify components, let's step through how a recipe is executed. And we'll dive into what a recipe actually means in a second, but I want to actually walk you through the recipe execution process before that. So once your recipe is deployed, and the recipe is simply a collection of folders and files, which is later packaged into a zip file. Once it's deployed and reaches the Cloudify controller, whether it's from the shell or from the web-based user interface, the Cloudify controller uses the cloud driver to allocate resources on the cloud that you're using. So if you're using EC2, that would use the EC2 RESTful API. If you're using Cloud.com, that will use the Cloud.com API, and so on and so forth. And essentially, the cloud controller instructs the cloud driver to allocate compute services for the deployed application. So it analyzes the recipe, understands how many resources needs to be allocated, and allocates them using the cloud driver. The next phase is actually bootstrapping the Cloudify agent on each of those VMs. So the Cloudify agent actually is not present. It doesn't have to be present on the kind of machine or virtual machine image that the cloud controller allocates. We can dynamically install and start the Cloudify agent on any image, basically, that supports Java, for that matter. The Cloudify agent is a Java component. Once the Cloudify agent is installed, it actually installed the actual service, and the service, in that case, it's Tomcat, but like I said, it can be any external process that you want Cloudify to manage. And again, like I said, it can be Node.js, it can be a PHP service, it can be Apache, it can be, I don't know, let's say a Ruby on Rails server, whatever application is using. All right, so now that you understood the recipe execution flow, let's dive into what a recipe actually is. So like I mentioned, the recipe is just a set of files and folders. And the recipe is consisted of essentially Groovy files. Those Groovy files conform to a domain-specific language, a DSL that we developed here, very intuitive DSL, we'll see it in a second, that describes to Cloudify various aspects of your application and application services. So we can see that we have, let me annotate that for a second, we can see that we have a top-level application DSL that describes which services, the service is actually a tier, like a web server or a database server or messaging server, which services your application is consisted of and how they depend on one another in terms of deployment order. And then for each such service, for example here Tomcat and MongoDB, which we're going to see today in the demo, we have a service recipe. And a service recipe essentially is composed of a service DSL file. And specifically here it describes the name of the service, how many instances to invoke, what kind of lifecycle events, how to install it, for example. So the lifecycle scripts that are described here are invoked when the service is installed. These can be shell scripts or Groovy scripts or even Groovy closures within the service DSL. The last bit is extensions for the platform. So in many cases, you would want to extend Cloudify in various aspects. For example, monitoring. I mentioned that you can actually monitor your own specific metrics. So the way to do it is to write a simple plugin, a simple Java plugin that would actually translate between Cloudify and your application. So for example, if you're monitoring MongoDB, it would use the MongoDB API to get the appropriate statistics that you want to monitor. And we'll see that in our demo later in the session. So that's what a recipe really is all about. One more thing that's not actually showing here is the actual, what we call the service binaries. So if you're installing Tomcat, for example, you must have a Tomcat installation in place to be able to install it. And it's intentionally not described within this diagram because Cloudify is smart enough to be able to download those binaries from a third-party location. So for example, you can actually instruct your recipe to download the Tomcat binary from the main Apache website or from your own local repository or basically wherever you want it to download from. All right, so let's have a look at what the DSL files look like. So the first thing we're seeing here is the application recipe. And we're actually seeing a PETCLINIC example. This is the sample application that we're going to use for this webinar. And essentially what you see here is that the application is consisted of two services. And again, if I kind of roll back one slide, right now we're looking at this file, the application DSL. So we're seeing that the name of the application is PETCLINIC Mongo. This is actually a simple port to Grails of the Spring PETCLINIC application, the sample Spring PETCLINIC application. In our case, it's been ported to Grails and it's using MongoDB as a backend database. And there are two services here. The first one is MongoDB, and the second one is Tomcat. The interesting thing here is that the Tomcat service actually depends on the MongoDB service. What that means is the Cloudify controller will orchestrate the deployment such that the Tomcat service will only be deployed and installed and started only once the MongoDB service is actually available. And it will determine whether or not it's available based on various I would say techniques, whether it's port detection. You can even hook into that mechanism and perform some sort of query against the Mongo database to make sure it's available. So everything here is kind of open and enables you to tweak with any phase in the process that you see fit. The next file or the next snippet we're seeing here is actually from the service recipe. Okay, so the service recipe, if we go back to the recipe slide here, the service recipe is actually what we're seeing here. So this is the part that describes each of the services and essentially what the name of the service is, how many instances, how to install it, how to start it, and so on and so forth. Okay, so in our case, we're seeing an example for a Tomcat service. The type is web server, and basically the type will determine how Cloudify will present and treat this service in the user interface. Initial number of instances, and a bunch of lifecycle scripts that tell Cloudify how to install, start, and stop this component. And these are just plain Groovy scripts. They are special in the sense that these Groovy scripts have some context information exposed to them. So actually, if you write an installation script, you can actually interact with the Cloudify environment to express dependencies, and we'll see that in a second. And this is where it gets interesting. So this is the monitoring configuration. So it's part of the service recipe, and we can see here that we can determine the monitoring class. So in our case, we're using what we're calling a JMX monitor, which is provided out of the box with Cloudify. This enables you to basically hook into any JMX-enabled MBean server, whether it's exposed by Tomcat or JBoss or WebLogic or ActiveMQ or whatever it is that you prefer to monitor using JMX, and tell Cloudify which MBeans to monitor. For example, here we're monitoring this MBean, and how to name this metric. Okay, and the name is very important. We'll use it later for both display purposes and for defining what we call alerts and scale. The nice thing about this mechanism is that it's completely extensible. So you don't have to use the built-in components that come with Cloudify. Instead of using a GMX monitor or an SNMP monitor, which are provided out of the box, you can actually use, let's say, a MongoDB monitor, which uses the MongoDB API, not GMX, to actually expose those metrics to Cloudify. And we're actually, we'll see how that works in the demo. You can use some sort of log scraping logic to actually monitor log files of another external process, and so on and so forth. You can use a JDBC driver to monitor the database of your choice. So it's very flexible in the sense that you can hook into this mechanism and expose any metric that you want. So now that we understood monitoring, let's talk a little bit about self-healing. So the first thing, the way Cloudify works is that it handles self-healing on multiple levels. The first level is what we call the process level. So if within the VM that you allocated a certain process crashes, for example, your Tomcat service, Cloudify will automatically restart it using the Cloudify agent that is located on the same virtual machine. But it's not doing just that. If the entire VM crashes, Cloudify's cloud controller will actually notice that and actually start the VM, start a new VM, and re-provision the failed instance onto that VM. So it's handling self-healing on multiple levels, both the process level and what we call the cloud or the VM level. Now let's talk a little bit about scaling. So in terms of scaling, Cloudify has two scaling modes. The first one is what we call manual scaling. And as part of the shell, you can actually issue commands to tell Cloudify to increase or decrease the number of instances of a certain service. So for example, if you're running a Tomcat service and you want Cloudify to start additional Tomcat instances, you can just type a simple command within the shell, Cloudify add instances, and add as many instances as you want. Cloudify will provision the compute resources required for that purpose using the cloud driver. So if you're running on EC2, it's going to use the EC2 APIs, for example, and provision the additional instances onto those newly allocated resources. What about what we call automatic scaling? So as part of the service recipe, Cloudify has a mechanism that's called scaling rules. And the scaling rules are very flexible in the sense that they allow you to use any of the metrics that were exposed by your metric configuration. So if you use GMX to configure your metrics, you can use those metrics to define those scaling rules. If you define your own plugin and exposed a certain metric that is not available for GMX, say using log scraping or the MongoDB API, which I mentioned before, you can use those metrics the same way you would use any other built-in metric in the platform. So in our case here, we're seeing a scaling rule that uses the active thread count metric. Okay, we've seen it previously in the recipe configuration. So this is actually, in our case, a metric that is gathered or collected through GMX, and this is the name it's exposed by. It's using the average value, or the average, I would say, value for all the instances in the cluster. So, and we have a bunch of other options here, of course. Average means that it applies to the average across all the instances of your service cluster. So for example, here it's going to take all the Tomcat instances that are running and calculate the average of the specified metric. You can also specify min and max, for, of course. So min means that all of the instances will be above a certain metric. Max means that at least one instance will be above or below a certain metric. So it's very flexible in the way you can configure. The next thing we have is lower and upper threshold. So what we do here is we specify as part of this rule the thresholds that are going to use that are going to be used by the Cloudify controller to determine or to proactively react to what's going on in the system. So in this case, if the active thread count goes below 20 for at least 1 second, what we're going to do is we're going to decrease one instance. If the active thread count goes above 80, by average of course, for more than 1 second, we'll decrease the number of instances by 2. So this is the proactive behavior that I mentioned before. And the nice thing here is that aside from just scaling the system, you can also do some other things. So you can fire alerts. Okay, and when we get to the web dashboard, we'll see the alerts that are available as part of the display. And this enables it to actually not just proactively react to a condition on the system, but actually notify your external systems or your administrator that something has happened. And you can also tap into this mechanism and implement a certain custom behavior. So in our case, it means to actually update a certain load balancer configuration. So if we're adding Tomcat instances and we're using, let's say, an Apache load balancer, an F5 load balancer, it's most likely that we want to tap into the API of those components and add or remove instances. So this is how scaling is handled using the recipe mechanism. Now Cloudify, although it's very open and essentially allows you to basically deploy or implement any application and deploy any application using the recipe mechanism, Cloudify is bundled with numerous built-in recipes and sample applications. So we're supporting out of the box Tomcat, JBoss, Ruby on Rails, MongoDB, which I mentioned before, Cassandra, and a bunch of other components that are, I would say, the most common application stacks in the market. We also support, I mentioned that Cloudify has a shared foundation with Zap. So Zap applications are actually a first-class citizen within Cloudify. So if you want to take advantage of the benefits of Cloudify for your Zap application, this is also possible using the Zap processing unit support of Cloudify. Okay, so although you can actually extend the recipe mechanism, we provide a lot of out-of-the-box configurations and recipes that will allow you to either get started in no time or take these recipes and use them as a starting point to develop your own recipes. All right, so without further ado, we'll go to the demo application. So I mentioned before that the demo application is actually a port of the PETCLINIC application, the Spring sample application. It's called PETCLINIC. It's been ported to Grails and is using MongoDB as a backend data store. What we're going to see is two things. The first thing is actually deploying the application on what we call a local cloud. This is an emulation of a cloud environment that's going to run on my laptop. And the next thing we'll do is we'll tweak the recipe a bit to add sharding to MongoDB. Since we're using a cloud environment, we can use more than one instance. So we'll add sharding to the MongoDB backend and deploy it on EC2. And sharding means actually adding a few more services for those of you who are familiar with MongoDB. The main takeaway here is that no changes were made to the application code. So all we did throughout this process is actually wrap an existing application with the Cloudify recipe, and we use the same application for deployment on a local cloud and on EC2. All right, so let's switch over to the local cloud. So what I'm going to do next is start the Cloudify shell. Okay, this is what it looks like. Now, essentially, the first thing I would do is bootstrap the local cloud. The bootstrap local cloud command actually creates the emulated environment, which I've mentioned before. I've already done this in this case. So essentially, all we need to do now is actually connect to the Cloudify controller endpoint. We can see here that we have nice, basically, tab completion support, the same way you would expect from a Unix shell. So we've connected to the local cloud, and the next thing we're going to do is we're going to install the application. Okay, so let's look for that command. Okay, so the command is install application, and I'm specifying the location of the recipe folder on my disk. Note that we have very nice tab completion capabilities for both commands and file names. Okay, so the installation process is starting now. And essentially, it's running the recipes of Mongo and Tomcat. And the next thing we're going to do is we're going to follow that installation from the Cloudify shell. So I'm connecting to localhost 8099. This is the default port in which the Cloudify user interface is running on. Okay, and we're switching to the topology view. And essentially now what we're seeing is, sorry, 1 second. And essentially now what we're seeing is the application installation in progress. We can see that the MongoDB service has already been installed, and the Tomcat service is being installed as we speak. Okay. Now let's take a look at this screen now. So the first thing we're seeing, the upper part of the screen, is actually what we call the application view. So we can see here that we can choose between applications. This is a multi-tenant monitoring console. So if you have deployed multiple applications, you can switch between them. In this case, we're seeing the PETCLINIC application here. Each of those boxes here, Tomcat and MongoD, represent a service cluster. It's not just an instance, it's actually a service cluster. So we're seeing that for the MongoD example service here, we have one instance out of one planned instances. So it means the service is actually up and running and everything's fine. We can see it in the check mark here. And the bottom line here is that we're seeing the guys, someone unmuted himself. Sharon, can you mute? Sorry about that, guys. Okay, so we're seeing that we have two services here. One is MongoD and the other is Tomcat. And the arrow here means that the Tomcat service depends on the MongoD service. So this is actually the representation of the application recipe that we've seen before. So the interesting piece here is the bottom part. Okay, so this is the status and topology part that we're seeing at the bottom of the screen. So we're seeing a couple of interesting things here. The first thing that we're seeing is the metrics. So we have a very nice view here of the basically the average of every exposed metric. So if you recall from the service recipe, we've configured, or we could have configured metrics that we would want to expose. And by exposing, it means that it would actually show up here in our UI. So we can see that we have the current active connections count of MongoDB. This is a Mongo-specific metric, and it's using a MongoDB plugin, monitoring plugin, that's using the MongoDB API under the hood. So it's fetching live information from the MongoDB instance we've just deployed. We can also see here what we call a balance gauge. And the balance gauge is designed specifically to handle clustered environments. So if you have a cluster of Tomcat instances or a cluster of MongoDB instances, what balance gauge will show is the distribution of readings for a specific metric. So if your cluster is unbalanced for a specific metric, for example, if the current active connections on one MongoDB instance is much higher than another MongoDB instance, the balance gauge would actually show that and turn into red, and the gauge would actually kind of flip and show us that the cluster is unbalanced. So this is a very intuitive view to actually understand that the cluster is not behaving properly. We can also see infrastructure services. So what we're seeing here is one machine. We're seeing hosts here, okay, whether they're virtual or physical. We're seeing one machine since I'm running on a local cloud. We're seeing the services that are deployed on this machine and the number of instances. For example, here we can see that we have one MongoD service, one Tomcat service, and one RESTful service is actually part of the management infrastructure that was created as part of the bootstrapping process. We can also look at things from a service instance perspective. So what we're seeing here is that we have one Mongo instance. We can see that the status is not that good because actually it's using a lot of, basically my laptop is kind of low on memory. I have a lot of things running here. So we see an indication for that in the user interface. And we can actually put it on a graph and basically choose any of the metrics that we have seen before and see them on a graph. So if you had, imagine you have multiple instances here, you can actually correlate between those instances based on any metric that you would expose. The last bit is we can actually see active logs of the Cloudify environment and our running service. This is actually a scrape of the MongoDB log. So you can actually, without SSHing to the machine, you can actually see whatever it is that's going on with your services from within the web-based user interface. Naturally, you can filter based on log level or regular expression. This is all very flexible. All right. So let's switch back to the presentation. So this was running the application on a local cloud. Actually, the next thing we want to do, of course, is just make sure that the application is running, which I haven't done. So that runs under localhost. 8080 / PETCLINIC Mongo. Oops, that's not showing up here. See what's going on here. Oops, okay, apparently something went down wrong here. Okay, laws of the demo. Okay, so let's actually see it running on EC2. Okay, so I'm switching back to the presentation. Okay, so the next thing we're going to do is we're going to deploy the same application on EC2, but we'll slightly modify the recipe. So what we're seeing here is that we've added 2 more services to the mix. And again, the nice thing about all of this process is that we didn't change the application at all. Right? The application remains the same. It means that we've enabled Mongo sharding, we've deployed everything on EC2, but we didn't change any of the application binaries. So in this case, we're adding 2 more services. One is MongoS. MongoS is the sharding service of MongoDB. So it basically functions like a load balancer. And the other one is MongoS CFG. It's actually another MongoDB instance that holds the cluster configuration. So the recipe itself will actually configure all of this cluster dynamically as part of the installation. The way it's done is using the what we call the contextual information that's available within the recipe. So what you can see here that this is actually a snippet of the startup script of the MongoS service. So when we start the Mongo sharding service, we can actually interact with the Cloudify environment. So we're waiting for a service. We're actually looking up for a service. It's called Mongo CFG. We're waiting for at least one instance of that service, and we're retrieving the host address of that service. And basically that way, they can actually tell MongoS where the Mongo CFG host is located. Okay, and that's very powerful. Think about that. It's actually a generic way to express dependencies in a cloud environment, and it doesn't depend on specific IPs or host names or anything of that sort. It calculates everything dynamically using the contextual information that's available for every Cloudify lifecycle script. All right, the last bit that we're doing to the recipe is we're adding a cloud driver configuration. Naturally, if we're deploying on EC2, we need to tell Cloudify how to interact with EC2. What is the user, an API key, what instance ID to use, what AMI to use, and all those details that are basically needed to use to actually interact with Amazon EC2. Okay, so once we've done all of that, those simple steps, we basically bootstrap the cloud environment. This is a one-time step. So essentially, if your cloud is not already bootstrapped with the Cloudify management infrastructure that I mentioned before, you can call the bootstrap cloud EC2 command. That will actually look for the EC2 configuration file that I've just shown and connect to the EC2 cloud and deploy the Cloudify environment on it. If it's already running, you can simply use the connect command the same way I showed within the local cloud demo previously. Okay, so that's it. The next thing is just install the application, and again, it's the same application, and let's see that in action. All right, so what we've done here, we actually have an EC2 environment that's already set up. Okay, let's try and connect to the Amazon environment here. Okay, and we see a bunch of instances running. Okay, these are the instances provisioned by Cloudify. Okay, so we can see here a bunch of instances. These were not started manually. These were started using the bootstrap command and as part of the application install command. And we're connecting to the Cloudify management console on EC2. So you can see the URL here. This is an EC2 URL. And we're seeing the status of our application. Let's switch over to the topology view. And we're seeing the same view that we've seen with local cloud before. It's a bit more complex now since we have more services. So for example, here we have 2 MongoD instances, not just one. We have a Mongo S service, and we have a Mongo CFG service. Okay, and hopefully the application will work on EC2. Oh, there you go. We have the application here. This is the actual PETCLINIC application. We can actually interact with it. This is fetching that data dynamically from the MongoDB database that was installed. We can actually find all the owners, look at their pets, and essentially everything you can do with this nice little application here. Okay, so using the same steps that I've shown before, we can actually see that Cloudify allowed us to install the same application on both the local cloud and on EC2. And because Cloudify is designed to be open, both in terms of the application stack that you're using and the underlying cloud, you can take the same application and install it on any other supported cloud. Okay, so let's switch back to the application to wrap up, to the presentation to wrap up. All right. So just a small summary of the key features that we have with Cloudify. We've talked about any application, any stack. Okay, using the extensible recipe mechanism, essentially you can deploy any application you want, and specifically applications that you already have and you want to onboard to a cloud environment. Automatic self-healing, we've discussed how that is happening. Cloudify is handling self-healing on both the process and the VM level. Auto-scale your way, so you can auto-scale Cloudify application not just based on trivial metrics like CPU and memory, but also application-specific metrics that are exposed as part of the Cloudify monitoring infrastructure. Automation of the entire lifecycle. We've seen an entire lifecycle of installing, starting, and accessing your application. Support for major cloud vendors, and essentially an open cloud interface to allow for integration with any cloud, and the cluster-aware monitoring and management that we've seen. Let's talk a bit about availability. So the Cloudify beta is already publicly available. You can register and get a copy at gigaspaces.com/Cloudify. Currently, we support, as part of this beta, the local cloud that I mentioned, the Azure cloud, the Microsoft Windows Azure cloud, and we have another thing here called Bring Your Own Node. So essentially, you can actually take any number of physical hosts and use them as an infrastructure for Cloudify. So this is already available for you guys to download and give us your feedback. We'd very much appreciate that. We have a release candidate planned for mid-December, which will include support for EC2, the same thing I just demoed, and the open cloud driver interface. So that means that you will actually be able to implement your own cloud drivers very easily and roll out Cloudify in your own environments, even if they're not yet supported out of the box. And we plan the GA release for mid-January. In that release, we'll support Cloud.com and OpenStack cloud infrastructures and a bunch of other providers. That's still to be decided. So I'd like to thank you all for taking part in this webinar, and we'll open it now for questions. So Sharon, I'll pass it on to you.
Thank you, Uri. Thank you for a very good presentation. I'd also like to present Nati Shalom, our CTO, who will also be here to answer during the Q&A session. I've been asked a few questions, so I'm just going to randomly choose them. The first question that was asked was, is Cloudify available as a service?
Okay, so I'll take that. Cloudify, essentially, it's not a service, okay? So it's a platform that you can download and install and use in your own environment. We will have special pricing for Cloudify for public cloud environments that's very similar to other platform as a service offerings, but essentially Cloudify itself is not a service. It's a distributable product.
Okay, thank you, Uri. The next question was, do I need an Amazon or Azure or any other cloud account to get started with Cloudify?
So the answer is most certainly not. We've seen in this webinar using the local cloud. So if you want to get started developing recipes and testing them, the local cloud is a perfect fit for that. I also mentioned the bring your own node capability, which actually enables you to deploy applications using Cloudify on a non-virtual environment. So you can take a pool of machines and use them as hosts for Cloudify. So you don't need a virtual or cloud environment to get started with Cloudify.
Okay, the next question is, does Cloudify work with the likes of Chef? And I believe Nati will be answering that one.
Yeah, so generally speaking, the answer is yes.
Double echo, guys.
And that means that if you already have a chef script, you could actually plug it into the recipe to the start and stop points within the recipe itself.
Okay, thank you. One last question. How does Cloudify support cloud bursting? Nati, would you like to answer?
So basically, for cloud bursting, what we have in Cloudify is the ability to not just run processes between clouds, but we can also replicate the data between clouds, which enables true cloud bursting. That means that when we send processes between, let's say, your private cloud and then offload some of the load into a public cloud, you'll have the data as well available for those processes, and therefore you could have the processes within, let's say, EC2 accessing the data that is already replicated into EC2 and effectively join the workload that you wanted to burst in the first place. And if the load goes down, we'll shut down that. The data will continuously be available there. So when we want to burst again, we just need to add those processes back into EC2, and we get extra capacity when we need to.
Okay, excellent. Thank you both very much. Thank you, Nati Shalom. Thank you, Uri Cohen. The recording of this webinar will be available to you on our website, and it will be sent to you after the event. Thank you for joining us, and have a good evening. Thank you, everyone.